Hello and welcome back to MathandBolt. So this is session number 10. So we'll be continuing solving more problems on differential equations using the method of variable separation. So let us begin. So here we have a differential equation. So we first rewrite this as y times square root of 1 plus x squared equals to negative x times square root of 1 plus y squared times dy over dx. Then we multiply throughout by dx, so that will give us y times square root of 1 plus x squared times dx, which is equals to negative x times square root of 1 plus y squared times dy. Now we're going to divide. So we need to get rid of this y on the left hand side and x on the right hand side. So that means we'll divide both sides by x times y. So that will give us 1 plus x squared whole divided by x multiplied to dx equals to negative square root of 1 plus y squared whole divided by y times dy. So as we can see, the coefficient of dx is purely a function of x and coefficient of dy is also entirely a function of y. So that means this is now in the variable separable form. Now let's integrate both sides. Then what we will do with the integration for both the two integrals will yield the same result except for the change in variable. What we'll do, we'll begin with the integration on the left hand side. So let's do that. So we have integration square root of 1 plus x squared whole divided by x times dx. So let's call it the integral I. Now we're going to suppose that square root of 1 plus x squared, let this be equals to some variable u, and then we square both sides. So that will give us 1 plus x squared is equals to u squared. And then from here we can solve for x. So x squared will be equals to u squared minus 1. Now we take this and differentiate both sides with respect to x. So we have 2x times dx equals to 2u times du. Or simply dx will be equals to u over x times du. Fine. Now let's substitute these values into our integral. So we have our integral then will be equals to integration. So in place of square root of 1 plus x squared, we have u divided by x times dx. So dx will be u over x du. So the x and x gets multiplied to give us x squared, and we know that x squared is u squared minus 1. Fine. Now what we'll do in the numerator, we will subtract 1 and add 1 whole divided by u squared minus 1 du, and this will be equals to u squared minus 1 divided by u squared minus 1 plus 1 divided by u squared minus 1 du. Or simply we have integration du plus integration du divided by u squared minus 1. Fine. Now we are going to use the formula that integration of dx divided by x squared minus a squared. So this is equals to 1 over 2a times log of x minus a divided by x plus a plus the constant of integration c. So in our case, we have u squared, so that means our x is equals to u, and our a value is 1. So that means we should get our integral will now become I is equals to integration of du, so that's u, plus 1 over 2a, so that will be 2 times 1 times natural log of, we have x minus a, so that will be u minus a. So we have u minus a divided by u plus a plus the constant of integration c. Fine. And we assume the value of u as square root of 1 plus x squared. So we will get square root of 1 plus x squared plus 1 over 2 times natural log of square root of 1 plus x squared minus 1 divided by square root of 1 plus x squared plus 1 plus the constant of integration c. Now let's go back. We have found the value of our integral. Let's go back to our original equation. So this is the one. So on the left hand side we have the entire integral in terms of x, and on the right hand side we have the integral in terms of y. So our final answer will be, so this value which is in terms of x, so we have square root of 1 plus x squared plus half times natural log of square root of 1 plus x squared minus 1 divided by square root of 1 plus x squared plus 1 equals to negative. So we have integration in terms of y, the same thing, where all the x's will get replaced with y's. So we have negative half natural log of square root of 1 plus y squared minus 1 divided by square root of 1 plus y squared plus 1 plus the constant of integration, and this is going to be the required solution to our given differential equation. So here we have another differential equation. So let's begin by rewriting it as square root of 1 plus x squared. So we'll consider this as a single term plus, so from the third and the fourth term we're going to take y squared as the common factor, so that will get multiplied to 1 plus x squared whole square root equals to, we'll take xy times dy over dx to the right hand side, so that gives us negative xy times dy over dx. This is equals to square root of 1 plus x squared. So this will be treated as the common factor from the first term and the second term, which will get multiplied to 1 plus y squared. So we can also cross multiply with dx. So this is equals to negative xy dy. And the square root can be written as 1 plus x squared times square root of 1 plus y squared dx equals to negative xy dy. Now what we'll do, we'll divide both sides with this factor and this factor. That means x times, I'm going to divide with x times square root of 1 plus y squared. So that should give us square root of 1 plus x squared all divided by x, so multiply to dx equals to negative y divided by square root of 1 plus y squared dy. Now this is in the separable form, so that means we can integrate both sides. Now to perform the integral on the left hand side, this is what we have already done in the previous problem, so I'll straight away write the result. Now that will be square root of 1 plus x squared plus half times natural log of square root of 1 plus x squared minus 1 divided by square root of 1 plus x squared plus 1. That's equals to, now to integrate the integral on the right hand side, we are going to multiply by 2 and divide by 2. And when we do the substitution by taking 1 plus y squared equals to some variable t, it's a very simple integral. This will give us the value negative square root of 1 plus y squared, and this integral is left as an exercise for you, plus the constant of integration c. So finally we should get integration as square root of 1 plus x squared, plus we'll bring this particular square root to the left hand side, plus square root of 1 plus y squared plus half times natural log of square root of 1 plus x squared minus 1 divided by square root of 1 plus x squared plus 1. And this is equals to the constant of integration, and this is going to be the required solution. So let us begin by separating the differentials. We have cosine of x times cosine of y times dy over dx equals to negative sine x times sine y. Now we multiply throughout by dx, so that gives us cosine of x times cosine of y times dy equals to negative sine of x times sine of y times dx. Now we'll divide both sides by, we'll divide with cosine of x times sine of y. The whole idea being we want to get rid of this cosine of x and make it completely a function of y, which will be the coefficient of dy, and on the right hand side we want to make the coefficient of dx free of sine y. Right. So we get cosine of y over sine y dy equals to negative sine of x divided by cosine of x times dx. So here we can see that the coefficient of dx is purely a function of x and the coefficient of y is dy is purely a function of y. So that means this is in the superior separable form, and now we can integrate both sides. So integration will give us, we have log of sine y equals to negative log of cosine of x. Now since everything is in logarithm, so let's take log of c, and this will give us log of sine y equals to positive log of cosine x plus log of c. We'll take this term to the left hand side and combine it with log of sine y. We are going to use a property here, so let me note down the property. So if we have log of a minus log of b, that will be equals to log of a over b, and this works for natural logarithms as well. So we have natural log of sine y divided by cosine x equals to log of c. Now we can get rid of the logarithm from both sides, which leaves us with sine y over cosine of x equals to c, and this is going to be our final solution. So don't think that this is the ratio sine over cos and that becomes tangent. Here we have different variables. This is sine of y, and in the denominator we have cosine of x. So the solution will simply stay as it is. So let's move on to the next problem. So we have the differential equation. Let's begin by separating the differentials first. So we have dy over dx equals to negative cosine of x times sine y divided by cosine of y. Now we're going to cross multiply, so we should get cosine of y times dy, that's equals to negative cosine of x times sine y dx. Now we will divide both sides with sine of y. That's because we want to make the coefficient of dx purely a function of x only. So we have cosine of y divided by sine of y dy, that's equals to negative cosine of x dx. So they are in the separable form, so we can integrate both sides, and this should give us the final result, which will be log of sine y equals to negative sine x plus the constant of integration c. Let's move on to the next problem. So here we have the differential equation. So let's begin by separating the differentials first. We have x times square root of 1 minus y squared times dx. So let's take the second term to the right hand side. We have negative y times 1 minus x squared dy. Now we will divide both sides with square root of 1 minus y squared times square root of 1 minus x squared. So that leaves us with x divided by square root of 1 minus x squared. So this is dx equals to negative of y divided by square root of 1 minus y squared dy. Now we can say this is in the separable form, so that means we can integrate both sides. Now what we'll do, we we'll do a little bit manipulation. So we are going to multiply with 2 and divide with 2. Let's do negative 2. So this will be negative half. Similarly, we already have a negative sign here, so this will be negative 2. So this will be 1 over 2. Now what we can do, we can solve both sides, both the integral, a very simple integral that can be solved using the method of substitution. And our final result should be negative square root of 1 minus x squared. And that is equals to square root of 1 minus y squared. Let's say this is the constant of integration c prime, or finally we should get square root of 1 minus x squared plus square root of 1 minus y squared equals to c, and this is the required solution to a given differential equation. Let's move on to the next problem. So we are provided with a differential equation. Let us begin by separating the differentials. What we will do, we will divide both sides with 1 plus e raised to the power of x times y plus 1, and that will give us y divided by y plus 1 times dy, so that's equals to e raised to the power of x divided by e raised to the power of x plus 1 dx. So this is in the separable form because we can see that the coefficient of dx is purely a function of x and the coefficient of y, dy, is purely a function of y. Let's integrate both sides. Now to integrate the integral on the left hand side, we're going to do a manipulation. So we're going to add 1 and subtract 1 from the numerator so that the entire rational fraction can be written as 1 minus 1 over y plus 1 times dy. Equal to integral e raised to the power of x plus 1 dx. So finally, when you integrate it, there's a very simple integral. So we will get y minus natural log of y plus 1 equals to natural log of e raised to the power of x plus 1 plus the constant of integration c. And this is the required, let's write down, this is the required solution. Let's move on to the next problem. So let's begin by separating the differentials. We have, so y plus xy, here we can take y as the common factor. So we have 1 plus x dx equals to negative. So from x minus xy squared, we can take x common. So that will be 1 minus y squared dy. Now we will divide both sides with y times x. So that gives us 1 over 1 plus x whole divided by x times dx equals to negative 1 minus y squared whole divided by y dy. So this is in the separable form. That means we can integrate both sides. So this will be dx over x plus integral dx equals to minus integral dy over y plus integral y dy. Solving this integral is going to give us natural log of x plus x equals to negative log of y plus half y squared plus the constant of integration c, and this is the required solution to the given differential equation. Let's move on to the next and the final problem. So here we have the following differential equation. So let us begin. So we have dy over dx equals to 1 minus x. Let's consider this as the first term, plus from the third and the fourth term we can take y as the common factor. So that will be multiplied to 1 minus x. So that means now we have two terms, and from both the terms we can take 1 minus x as the common factor. So that will get multiplied to 1 plus y. So this is dy over dx. Simply dy divided by 1 plus y equals to 1 minus x times dx. So this is in the separable form. Now we can integrate both sides. So integration of dy over 1 plus y, so that will be natural log of 1 plus y equals to integration of 1 dx, so that's x minus integration of x dx, so that will be half x squared plus the constant of integration c, and this is the required solution to a given differential equation. Thank you.